In this video, we shall look at how to do integration using the technique of integration by parts. Let's see at some of the concepts behind integration by parts. Assume that you have two functions, u and v. They are both functions of x. Now let's assume that we want to differentiate the product of uv. Using product rule, we can write this derivative as v du dx plus u dv dx. Now let's integrate the above line with respect to x. d dx uv dx equals v du dx, integrate that with respect to x, plus the integral of u dv dx integrated, of course, with respect to x. The term on the left hand side is simple. You are integrating a derivative, so the answer is just u times v. Now let's look at the first term on the right hand side. I'm going to write du dx as u prime and dv dx as v prime. That is just a shorthand to denote the derivative with respect to x of these functions. So the first term on the right hand side is just v u prime dx, and the second term is plus u v prime dx. Rearranging the term a little, u v prime dx equals uv minus v u prime dx. The last formula, applying this formula in integration, is called integrating by parts. Let's see how we can use this formula to integrate functions. How do we integrate this function, x times cosine of x, with respect to x? We need to choose one function to be u and the other function to be v prime. Because remember, this integral is uv prime dx. I'm going to choose x as my u, and v prime is the remaining term, which is cosine of x. So what that means is u prime is 1, because the derivative of u with respect to x is 1. And when you integrate cosine x, you get v, because to get from v prime to v, you need to integrate v with respect to x. And that will just give you sine x. Recalling the integration by parts equation, which is the following. Let's substitute these information in this line. So the left hand side is what you want to evaluate, x cosine x dx. The first term on the right hand side is the product of u and v, so that is just x sine x minus integral of v times u prime. V is sine x and u prime is just 1. So you see that we can solve this original integral, which is that, quite easily. Integration of sine is minus cosine, and don't forget the overall integration constant. So this is the answer for that integral. So this is how we use this formula to integrate functions. Namely, this is how integrating by parts work. Let's look at the second example. We want to evaluate I, which is that integral. So step 1 is to choose your u and v prime. I'm going to take u to be x squared plus 1 and v prime to be cosine of x. How do I know which function to choose for u and which one to choose for v prime? A simple rule of thumb is whatever you choose for u, its derivative, namely u prime, should be a simpler function than the u itself. So in this case, it's 2x. It has a lower power than x squared plus 1. Remember, this is just a guide. Had you chosen v prime to be x squared plus 1, when you calculate v, you will get a more complicated function, such as this, 1 over 3 x to the cube plus x. So you see this is more complicated than that. And the line that follows in the technique of integration by parts would be more complicated. So this would likely not to work. So let's get back to our original choice. V prime is cosine of x, so v is just sine of x. That's what you get by integrating cosine of x. So let's put these information inside integration by parts formula. So I is u times v, so u is x squared plus 1, v is sine x, minus the integral of v and u prime. So u prime is 2x, v is sine x dx. And now we have to apply the technique of integration by parts one more time to this term. And let's just do that. And for that we need a new set of u and v. So I'm going to take the new u to be 2x, so that means u prime is just 2. My new v prime is sine x, so that means my v is minus cosine of x. So that integral will simply becomes the new u times the new v, which is minus 2x cosine x minus v u prime. So u prime is 2, v is minus cosine x, so that will make this sign a plus, cosine x dx. And the answer for this integral alone is just minus 2x cosine x plus 2 sine x. Let's hold the integration constant for now. So substituting this in here, we get this term. So now let's simplify the I. The I will become x squared. Note, sine x minus 2 sine x is minus sine x. So it will be minus 1 sine x plus this term, which is 2x cosine x, plus an overall integration constant, let's call it d. And this is the final answer to that integral. What about this integral? So again, let's choose u to be x, so that means u prime is just 1. It gets simplified. Now v prime is the remaining function, which is cosine squared x. Using trigonometry identity, cosine squared is just half cosine 2x plus 1. So that means your v, which is the result that you get by integrating this, will be 1 over 4 sine 2x plus 1 over 2x. Applying integration by parts formula, j equals, the first term is u times v, so that is x times 1 over 4 sine 2x plus half x minus the integral of vu prime. U prime is 1 and v is this. So that means you have to integrate 1 over 4 sine 2x plus half x. Integrate that with respect to x. So you see, another rule of thumb is that the resulting integral in the process of integration by parts will be much simpler than the original integral that you begin with. So let's proceed with evaluating the integral j. So the first term is x times 1/4 sine 2x plus half x minus integrating 1/4 sine 2x will give you minus 1 over 8 cosine 2x. So that minus will kill this minus, will make it a plus. So 1 over 8 cosine 2x. Integrating half x, you get, don't forget this minus, minus 1 over 4x to the power 2, plus an overall integration constant, let's call it e. Let's simplify this. Half x squared minus 1/4 x squared, you will get 1 over 4 x squared. And then you have this term, which is 1 over 4 x sine 2x. And finally that term, which is 1 over 8 cosine 2x plus an integration constant e. And this is the final answer. Now let's try to do this integral here. Now there are 3 functions, but we can combine the last 2 using trigonometry identity into something more manageable. So let's set again u to be 2x. So that means u prime is 2. Your v prime is the remaining terms. Cosine 3x cosine x. Using trigonometry identity, we can write cosine 3x cosine x as half cosine of 4x plus cosine of 2x. So what that means is v is the result of integrating that is just 1 over 8 sine 4x plus 1 over 4 sine 2x. Now let's apply the integration by parts formula to evaluate j. So j is u times v, that is the first term. So 2x times 1 over 8 sine 4x plus 1 over 4 sine 2x minus the integral of u prime v. So u prime is 2. Your v is this entire thing, which is 1 over 8 sine 4x plus 1 over 4 sine 2x dx. So let's write down all the terms. J equals 2x 1 over 8 sine 4x plus 1 over 4 sine 2x. Let's take the 2 out of the integral sign, so it's minus 2. When you integrate sine 4x with respect to x, you get 1 over 4 cosine 4x. Multiply that 1 over 4 with 1 over 8, you get 1 over 32 cosine 4x. Don't forget the minus. And then for the second term, similarly, you have minus 1 over 8 cosine 2x. We note this minus will kill these two minuses, making them positive, like that. Also, that this will make it a 16 here and a 4 there. Likewise, this would make this a 4 here and a 2 there. So your final answer for J is x over 4 sine 4x plus x over 2 sine 2x plus 1 over 16 cosine 4x plus 1 over 4 cosine 2x plus an integration constant d. Thank you for watching.